1, but I'm going to do number 2 and number 4. I'm going to do these, probably all the work on another piece of paper because it's going to take quite a bit of work to figure this out. Lewis wants to carpet the rectangular floor of his basement. The basement has an area of 864 square feet. An area is everything inside. The width of the basement, so the width is smaller, it's 2/3 of the length. If this happens to be the length, this is 2/3 of, which means multiply, so I'm just going to put this fraction next to this variable because that means multiply. It's 2/3 of the length. It's shorter. These two numbers should equal 864. Now I have to find the length. There are many ways to do this. I'm going to show you 2 ways. The first way I'm going to show you is guess and check. So I'm going to go to another piece of paper. I'm going to write this down, 864. This is the length, and this is 2/3 of the length. All right. I'm going to make a chart. The chart will have length and then 2/3 of the length. I'm going to start guessing at what this could be. What two numbers could multiply and equal 864, but the second number has to be 2/3 of the first number. And remember, of always means multiply, so don't forget that. Okay, I'm going to start with a big number because I've got 864 here. So why don't we try 40, okay? I'm going to find 2/3 of 40. If I tried 40 as my length, now I need to find 2/3 of 40. I'm going to multiply that by 2/3. Put this over 1. I'm already seeing a problem because now I have 80 over 3. I know that's not going to go evenly. So 40's out. Let's go a little lower. Why don't we try 38? 38 times 2/3. Put this over 1. Okay, 38 times 2, 76 over 3. And that, let's see, 3 goes into 7. Let's do the division over here. 3 goes into 7 twice. 16. Oh, that's not going to be even. So with 38, I got 76 over 3, and that's also not going to work. I should be thinking about this 3, because in the end, I'm dividing it, right? So let me think of a number that would divide evenly with 3. I'm going to try 36, because I know that divides evenly by 3. So I'm going to find, if I try 36 as the length, I need to find what 2/3 of that is. So 36 times 2/3, I'm going to put this over 1. Easily can do that, right? That's 3 divided by 3 is 1. And then 36 divided by 3 is 12. And 12 times 2 equals 24. Okay, now if this actually works, let's see if it equals 864. So 36 times 24, 6 times 4 is 24. 12, 13, 14. 0 is a placeholder because I'm done with the 4. Now 2 times 6, which is 12. 2 times 3, which is 6. 1 more is 7. Ooh, yes, look at that. It does work. So it looks like the question says, what is the length? The length is 36. Okay, now I'm going to show you another way. This way is using, it's using algebra, okay? Balancing out your equation, solving for your variable. These are all terms you may not 100% be familiar with. That's okay. I'm just going to do this math. This is very advanced math. If you do not understand it, that is okay. But I'm going to show you a different way to solve this problem. You know that the area equals length times width. You have some of this information. You have the area. You also know that the length happens to be, the width happens to be 2/3 of the length. So I'm going to write the same variable here, L. I'm not going to write the W, because when you solve in an equation, it's easier to just have one variable. And now I'm going to combine these terms. If I have L, times 2/3 of L, that's like saying I have two L's. I have to multiply them together, except one of them isn't totally a whole L. It's 2/3 of an L. So I'm going to write it like this, okay? That's how I can combine these two terms. They're like terms because they have the same variable, and I can put them together with a square showing that there's two, and then this is 2/3 of it. Now, when you're solving for a variable, you use PEMDAS, but you use it in the opposite order because you are balancing out your equation and putting things over here onto this side. So I'm going to start with addition, subtraction. I don't see any addition, subtraction, so I'm going to move on to multiplication and division. I do see multiplication. I see 2/3 times L. I know that when a number is next to a variable, it means multiply. So I'm going to divide by 2/3. I'm going to divide by 2/3. So that would look like this. 864 divided by 2/3 is going to equal, now when I divided this, because it was being multiplied, that made it go away. So now all I have is L squared. Okay, and I know that when I divide and multiply fractions, I have to have a numerator and a denominator over a numerator and denominator. So I put this over 1. I also know that when I divide fractions, I don't divide fractions. I always multiply and find the reciprocal. I keep this number, I change this to a multiply, and I flip this. Keep, change, flip. Kept this, changed it to multiply, and I flipped it. I found the reciprocal, 3/2. Now I can just multiply this across. Actually, before I do that, I'm going to cross cancel to make this easier. I'm going to divide them both by 2. 2 divided by 2 is 1. 864 divided by 2 is 432. So now I have 432 times 3. 432 times 3 is 1,906 equals L squared. Okay. Now I'm done with multiply, divide. I'm going to go to exponents. I do have an exponent. This is a square. That means two L's put together. Okay, so I'm going to find something called, I'm going to rewrite this, I'm going to find something called the square root. Square root looks like that. Square root means I'm going to find two numbers that are the same that multiply and get this. For instance, the square root of 25 is 5. The square root of 16 is 4. 4 times 4 is 16. 5 times 5 is 25. Two numbers, which I do not know what they are, multiply and become 1,296. In order to do this, you have to make a big old factor tree. I'm going to put this factor, actually, I can just scroll up. There we go. So I'm going to factor this. Let's try 12, okay? Oh, that goes in, 12 goes into 12 once, 12 goes into 96 8 times, right? And if I did that, it would look like divide by 12, that goes in once, bring down the 9, that does not go in, bring down the 6, 96 is 8 times, right? Okay, so I know it's 108. And I factor, when you do a factor tree, remember you're factoring until you have prime numbers. Prime numbers cannot have only 1 in itself, right? So 3 is prime. Only 3 times 1 makes 3. But 4 can be 2 times 2. These are prime because the only thing that makes 2 is 2 times 1. 108 is 12 times 8. Let's see. Yes, 12 times 8 is 108. Okay. This is 4 and 3. 3 is prime. 4 is 2 and 2. And 8 is 2 and 4. And that factors out to 2 and 2. Okay, I hope you follow that. Now, with square root, you find everything that goes together, matching a pair. So I have a 2 and a 2. I write it down. I have a 2 and... Did I do something wrong here? Let me check really quick. 3 times 4. 2, 4 and 3. 8 is 2 times 4. Yep. Okay. All right, so I have those two, this 2, and this 2. I have this 3 and this 3. I have this 2 and this 2. And let me see if I did something wrong here. Oh, whoops. 12 times 8 does not equal 108. It's 12 times 9. Okay, there's a mistake I made. 1 second. That's going to change this and this. So, sorry about that. Okay. This is still 2 and 2. I made a mistake. 12 times 9 equals 108. And 9 is 3 and 3. Now I'm going to match everything up. Okay, I have 2 2's here. I'm going to write that down once. I have 2 3's here. I'm going to write that down once. I have a 3 over here and a 3 over here. I'm going to write that down once, and I have 2 2's right here. I'm going to write that down once. I take all these numbers and I multiply them. 2 times 3 is 6. 6 times 3 is 18, and 18 times 2 equals 36. So that is what L equals, all right? And that's what we got over mouse. That's what we got over here, 36, all right? And number 4, I will do on the next page.